Hello students, moving on to the next topic, three-dimensional rotation. Recall our previous topic, that is 2D rotation concept. So rotation is one of the kind of the transformation. Recall the equations what we have discussed earlier, x cos theta minus y sin theta, that is for x dash, and y dash x sin theta plus y cos theta, right? Recall these things or these topics already we have discussed with respect to the previous module, right? Module number 2, 2D transformation. I have clearly explained you how to derive the equation. Recall the things. Say we have to consider that is for two-dimensional parameter, whatever it is. Even same is applicable for the 3D as well. Okay, so one particular point, let it be P. Consider this as P. So this will become let it be P dash, right? Join these two lines, right? P and P dash. Hope it is visible. Then we have considered the angle of rotation, right? Theta as well as phi. The initial value, this is the initial angle. So this particular value we have considered theta, then somewhere here we have considered phi. So cos of theta plus phi will be the total value by considering the x-axis as the reference point. That cos theta and sin theta, x-axis is denoted with respect to cosine of the angular displacement, and y-axis is denoted with respect to sine of the, because opposite side, right? Sine of the angular displacement. So recall all these topics, you will come to know how the equation comes, right? So if you know that equation, these concepts will be definitely easy for you people, right? Now we are writing it for 3 dimension. Now see how 3 dimension rotation looks is. So for by default z we are considered as the parallel plane. Okay, that is for that is what the default axis we are giving. Anyway we can even take we go with the x-axis rotation, and we can go with the y-axis rotation as well. Okay, these are the scenarios. As you can see, the person is viewing from z-axis, right? A kind of rotation, z-axis rotation or z rotation. Here see the person is viewing from x-axis, it's particular rotation or x rotation. This is what y rotation is. Check the pointer. See, 3 diagrams we have. Z, here we have x, as well as here we have yeah, it is visible, right? Y rotation. So along with the z-axis, what are the equations to be taken? I told you earlier the equations x dash as well as y dash. What is x dash? X cos theta minus y sin theta. Y dash is x sin theta plus y cos theta, isn't it? So these two equations, how these equations came? Just now we have discussed about this by considering this particular diagram. Go back to the previous videos and check. If you still have the doubts, check. I told you to note down the equations and derivation part, because it is that particular concept is very important. If you have not, you have to watch those videos once again and note down the things. If you understand that, then definitely these concepts will be easy. So x dash and y dash, same equation you are supposed to write. The equation what you have derived for 2D, the same equations. X dash equal to x cos theta minus y sin theta, y dash equal to x sin theta plus y cos theta. This is now very important. So z axis rotation we are speaking about, there is no variation for z. Z dash equal to z, no variation for z. Okay, z dash equal to z. These things you have to remember. Whenever you are speaking about x-axis rotation, x dash should be x. Whenever you are speaking about y-axis rotation, y dash, the new value for y, dash is nothing but, right? Where P is a point which is represented as, by considering the 3 parameter x, y and z. So what will be the value of P dash? P dash value will be, say here, x dash comma y dash comma z dash. So what is x dash we are deriving, right? It is visible, I hope. Then y dash value also we are deriving, and since we are speaking about the z axis rotation, check here along with z axis. So z dash value remains same as the value of the z. So in the homogeneous coordinate form, the 3-dimensional z axis rotation, how to represent it in the homogeneous coordinate system. right? Homogeneous coordinate system, here you are supposed to take 4 cross 4 matrix again, because that is the rotation matrix, because earlier for the 2D model we have taken 3 cross 3 where the third parameter we used to mention the constant values. So here the fourth parameter will be the place to keep the constant values. Fine. Now you have to refer to the equations, and you should understand how to write the how to mention this matrix format. So actually the meaning of this statement is P dash which is equal to rotation, right, which is equal to, this is equal to, okay, fine, okay guys. So P dash equal to rotation, okay, what is the angle? So rotation along z axis, so I will, let me mention it as r of suffix z. Z axis rotation, what is the angle? Angle of rotation taken is theta. So r of z, rz of theta you can say, in multiplication with initial value of the point. What is the initial value of the point? It is p, right? So r of theta rotation matrix, the contents of the rotation matrix. How to mention the contents of the rotation matrix? Go back to the equations, check the equation. So x dash equal to x cos theta minus y sin theta. What is the coefficient of x? First row, equation number 1. This is equation number 1, okay, which to be mentioned in first row. This is equation number 2, hope it is visible, right? That is y dash thing is equation number 2, z dash is equation number, what is the equation number? Equation number 3, right? X dash equal to x cos theta minus y sin theta is the equation 1, y dash equal to x sin theta plus y cos theta is equation number 2, and z dash equal to z, equation number 3. Equation number 1 content should be mentioned in the first row, equation number 2 in second row, as well as 3 in third row. That's it, constant value in the fourth row. So what is the coefficient of x? Check here, check the equation and check the contents of the rotation matrix. So x cos theta, x into cos theta, coefficient of x is cos theta, check, cos theta is mentioned, okay. Then check the next parameter. Next parameter is what? Y sin theta, x cos theta minus y sin theta. So coefficient of my y is what? Minus sin theta, isn't it? So it is minus sin theta, that is coefficient of y is minus sin theta. Now, there is no z parameter. Check, is there any z parameter? No. So coefficient of z will remain 0. 0 into z is 0. Third parameter is 0. Fourth parameter should be 0 only, as per our previous discussion. Check the second row, for that is equation number 2. Equation number 2 is what? Y dash, x sin theta plus y cos theta. Coefficient of x you mention here, sin theta. Coefficient of y, that is cos theta. Z, there is nothing. Fourth parameter is 0. Then z dash equal to z is the third equation. This is very important. Z dash equal to z. Is there any, check, is there any x parameter here? No. Coefficient of x will remain 0. 0 into x is 0. So you have to mention 0. There is no y parameter, so 0 into y, right? Mention here as 0. Third parameter 1 into z, it is 1 into z. That means coefficient value is 1. Fourth parameter remains 0, and finally the constant value 0 0 0 1, isn't it? Then mention the value of p. That's it, right? That is what the rotation matrix for x-axis rotation. Now y-axis and z-axis rotation, how to perform? Go through the statement, hope the statement is visible. So transformation equations for the rotations about other two coordinate axes, that is y and z, can be obtained with a cycle permutation of coordinate parameters x, y and z. That is, in place of x you are supposed to substitute y, in place of y you are supposed to substitute z, and in place of z you are supposed to substitute x. Cycle parameter, right? X to y, y to z, z to x. This is how you have to go for the substitution. You will be getting the equation. So x-axis rotation, this is very very important. For x-axis rotation, x dash should be x. For z-axis rotation, z dash equal to z, no? If that is true, then for x-axis rotation, x dash, the new value of x should be same as that of the x. Y is dash and z dash is easily, it can be easily computed. So how you have written the equation that x and y, you are supposed to, in the previous equation, that is previous equation x and y, in this particular equation replace x by y, y by z. Listen carefully, x by y, y by z. Obtain the, so we will be getting y cos theta minus, in place of y you have substitute z, no? So y cos theta minus z sin theta will be getting, that is for y dash, and z dash x by y, that is x dash should be replaced by y dash. What is y dash then? Y should be updated with replaced by z. So z dash equal to x by y, no? Y sin theta plus z cos theta. Check here what is the equation you are getting. See, y dash equal to y cos theta minus z sin theta, right? Z dash equal to y sin theta plus z cos theta. That's it. X by y, y by z you are supposed to replace. That's it. That is for x-axis rotation. Similarly, we will be getting y-axis rotation. So for y-axis rotation, please understand, y-axis rotation, y dash should be equal to y. So z dash as well as x dash will be getting in the same way, how we have discussed it, no? In the same way you can derive the equations. If you know these equations, then easily you can write the contents of the matrix, right? So just go through the document which I have already shared in the group, note down these equations as well as matrix contents. Let us continue our discussion in the next video. So all the three types of rotation, in the sense x-axis rotation, y-axis rotation and z-axis rotations are very very important. If you know about the z-axis rotation, easily you can write the equations for x as well as y-axis rotations. Let's continue our discussion in the next session. Thank you for watching.